All right, let's go over 6.2 number 41. So 6.2 number 41 says find the volume of the solid that results when the region enclosed by x equals y squared and x equals y is revolved about the line y equals 1. Now on this one I already kind of got started, and I looked at Sylvester's solutions that he posted, and he did some good things, but then we might talk about it, I guess, as we progress through the problem. But let's take a look. So like I said, I kind of got started on this already, and I actually made a mistake when I was first drawing the picture. But anyway, here's what we've got. So x equals y squared. If you solve for y, that's just y equals square root x, and so it looks kind of like this. And then x equals y, that's the same thing as y equals x, so it's just a straight line. So and notice that they meet at 0, 0 and at 1, 1. So this is the region that you're interested in rotating. Now we're going to rotate this about the line y equals negative 1. So you're going to rotate it, and it's going to end up down here at negative 2. So I first drew it at negative 1, but it shouldn't be there. Anyway, so you can kind of imagine rotating around that line y equals negative 1. So again, if we take an arbitrary slice, and in this case we need to take vertical slices because that's how we get washers. If we take horizontal slices, we're not going to get washers. We're going to get some weird looking shapes. So we take vertical slices, that gives us washers. And the question is, what is the radius of the outer circle, and then what's the radius of the inner circle? So now here's where you might get into a little bit of trouble, because you might think, well, from here to the top portion, right, that vertical distance should be, since this is the function x equals y squared, if we solve it for y, if we solve it for the height, which would be y, right, we would get y equals square root of x. And so you might think, well, the radius for the outer circle is going to be square root of x. That would be true if you were revolving about the x-axis, but you're not. You're revolving about the line y equals negative 1. So actually, for the radius, you need to add on this additional part down here, right, which is going to be, a plus 1 to the radius. So that altogether, the radius is actually square root of x plus 1, right? That's the radius of that outer circle. So maybe I'll call this r sub o for outer. That's going to be square root of x plus 1. Now for the inner circle, because remember, you have to do the outer circle and then minus the inner circle in order to get the area of that washer. So for the inner circle, r sub I, same deal, right? So from here to here, that vertical distance is just x, because it's the line y equals x. However, the radius would have to be then x plus 1. So it's x plus 1 for the radius of that inner circle. Okay, so then the area of just a randomly selected cross-section, the area is going to be pi times radius of the outer circle squared. So pi r squared, we'll say root x plus 1 squared minus x plus 1 squared. And that's that. So then the volume, of course, for the volume, you're gonna find the area of each of those washers between 0 and 1, and then you're going to add them up. So the volume is going to be the integral from 0 to 1 of this stuff. Okay, and that's that. We can take this, I mean, you can see that this is going to end up actually pretty nicely, but we can take it a step further just so that it maybe looks a little bit less scary. So we can expand this. Root x times root x is, of course, just x. And then you're going to have a 2 root x, and then a 1. And here you'll have x squared, 2x, and 1. And taking it one step further, you'll have a negative x squared, it looks like. And then it looks like you'll have an x minus 2x, so a minus x. Get rid of those terms. Then you'll have a 2 root x, which I'll call x to the 1/2 power. And then the 1 minus 1 cancels. And that's that. Okay, so I'll leave the rest to you. That should lead you to the correct answer now. So again, that was 6.241.